So we looked yesterday at binomial distributions, but today we're going to look at some of the, more specifically at the equation and the requirements, because I didn't want to overwhelm you with information the first time you were dealing with it. Obviously we identify that it's discrete data and it's a yes or no, it's a success or a failure. Bernoullis are an example, but Bernoullis assume one trial, whereas binomial we're dealing with a number of trials. Now, with the number of trials, for it to be a binomial needs to have two conditions met. It must have a fixed number of trials and the probability must remain the same. And that sounds pretty simple, but if you're thinking about things like drawing a card out of a deck, unless you replace the card, you're going to be affecting the probability, so you can't use a binomial. So very, very important that it's got with replacement, otherwise we can't apply the rules. So here we've got the equation. It looks quite gross, but when you think about what's actually going on, it's not too bad. We've got probability of x is equal to r is equal to NCR, which is just a combination, and we're familiar. That's often denoted as NR. Cool? Where N is the number of trials and R is the number of successes. A reminder for those of us who forgot what that equation looks like. It is N factorial over N minus R in brackets factorial, R factorial. Cool? And we recall our factorials are progressively decreasing multiplications. So it's that multiplied by the probability of success to the number of, to the pair of the number of successes, multiplied by the probability of failure to the number of failures. Now sometimes this is represented as Q, but I don't want you having to remember another variable. Yeah.
I thought R was number of successes.
Yes, but N minus R. Oh, I see what you mean, thank you. That is R. Thanks. So we're going to go through a couple of examples, and these can pop up in tech-free questions. They're not often, but they can. They're a lot easier tech-active. There's a little button you hit in your calculator. It makes life very easy. But you need to know how to do these tech-free. So the first thing that you want to do when approaching one of these questions is write down what you know. I roll a die 6 times, determine the probability of getting 2 4s. So what's the probability of success? P is equal to?
Probability of success.
1 on 6. Cool? So the probability of rolling 1 4 is equal to 1 on 6, and the number of trials is equal to 6. And my value that I'm looking for is 2. So I want the probability that x equals 2. So if I was drawing this equation out, I would write probability x equals 2 is equal to 6c2 times 1 on 6 to the power of 2 times 5 on 6 to the power of 4. And I should have picked a better example, but I have made one that I want to go with. And that will give us 6 factorial over 4 factorial times 2 factorial times 1 on 6 squared times 5 to the power of 4 on 6 to the power of 4. Cool? Yep.
Is that 4s or?
Which one?
Top, really top, no question.
4s.
Oh, you know, 2 number 4s.
Yep. Now, with our factorial, I want to do this over here. 6 factorial over 4 factorial times 2 factorial. Well, 6 factorial is 6 by 5 by 4 by 3 by blah blah blah. And this is 4 by 3 by 2 by blah blah blah. I'm going to cancel those out. Good? And I should be left with 6 times 5 over 2. 2 by 1, but I have to write that. Are we good with that? So I can replace that with 6 by 5 over 2 times 5 to the power of 4 over 6 to the power of 6. Can we maybe see something that I can do here to simplify that? I can cancel this 6 with one of those 6's and leave that as a 5. I can add these 2 up, and I'm left with, and like I said, I should have picked a better example, but I haven't. 5 times 2 times 6 to the power of 5. Cool? Whatever that is. Now I'm going to show us how we can do that in a really simple step without a calculator. I want you to pull your calculators out. it out. So with our calculator, I want us to go menu, statistics. There should be a distributions button. I think it's F5, is that correct?
Yes.
F5, and then you might, I think it's right on the far side, or maybe it's F5 again, binomial. And then you'll see three options, BCD, BPD, and inverse B. When we're looking for a particular point, like an individual value, it's BPD. So BPD, when you click that button, if you've done this before, if you've been in binomial before, it'll come up with var. If not, you'll have to change your list to variables. And then it will give you the following. It'll give you X, num trial, or num, what is it, num? Num, it's NUM, isn't it? Num trial, num T, and then it'll give you P. In this situation, our X is equal to 2, our number of trials is 6, and our probability is 1 on 6. And if you shove that in, you would get exactly the same as this, and I want you to confirm that's exactly what we get. Partly because I haven't checked that answer is actually correct. And I want to make sure my method is appropriate. It is correct. Even a broken clock's right twice a day. It is. Only when I'm talking to you. Why's that? Only when I'm talking to you. Why's that? Okay. That is true. I do drop it a lot for certain techniques that are less conventional than others. Alright, so we're happy with that. That makes perfect sense. If you are not sure on how to do that on your calculator, let me know before I move on. What is it, 20%? Around 20%, yeah.
It's like 0 to 9.
Perfect. Okay, so now we're going to look at the same example, but instead of doing the probability that x is equal to 2, I want the probability that x is less than 2. Now before we go any further, I want you to write out what that is. So what are my options? If it's less than 2, what are my options? The probability that x is equal to and the probability that x is equal to? Cool.
How can you roll 0 and I can roll 0 and
You can roll 0 fours. So this is the number of fours, not the probability of getting a 2. This is the probability of getting 2 fours. And that would be the probability of getting 1 4, and that would be the probability of getting 0 fours. So for this equation here, what do you notice? Is there a simple, like, I just shove in that equation, or what do I have to do? I have to think and I have to add up the values below. Like I have to apply the same formula I was applying before, but for each term. And I know that for the students yesterday who got to this part of chapter 8.2, how would you describe that experience? Dry, very dry, not very fun. So I'm just going to show us how we do this and a few tricks, and then I'll show you how to do it on the calculator. So the first thing I'm going to do is Px equals 1. Now you should be able to fill this out on your own. Cool. And that will give us 6 times 1 on 6 times 5, pair of 5 on 6 to the pair of 6, which would equal, that's 5. They're going to cancel out, and I'm left with 5 to the pair of 5 over 6 to the pair of 6. Nope, to the pair of 5 again. What's 6 factorial divided by 5 factorial times 1 factorial?
6.
Just 6. 1 on 6 they cancel out, so I'm just left with the second bracket, which is 5 on 6 to the power of 5. And then probability that x is equal to 0. Now this is an interesting one because we're going to get 6, 0 times 1 over 6 to the power of 0 times 5 on 6 to the power of 6. What are these? What's this one going to be? 6 factorial divided by 6 factorial, so that equals 1. Anything to the power of 0 is? So we're just left with 5 on 6 to the power of 6. Now you'll notice these are tech-free problems, correct? What do you notice about the tech-free nature of these tech-free problems?
Tech-free.
Yeah, do you reckon you could do those in your head? No. So what would make these much more possible to do in your head? What style of questions would you expect to see in an exam? Well, smaller numbers of powers and 1 on 2s and 3s. Okay, so you wouldn't expect to see 1 on cell 3 on 17 to the power of 3, because I wouldn't expect you to know what 7 to the power of 3 is. But is it fair for me to assume that you know what 4 to the power of 3 is? Yeah, so things like that will pop up. 5 to the power of 6 and 6 to the power of 6 is too high. But that's because I made a bad question. Cool, happy with that. Now, I don't want you to get too lost, but this condition here, we can do a few different things because of what I just showed you with these two cancelling out. But I'll come back to that later. We don't need to get too clogged down. What I do want you to get clogged down into though is how to do this on your calculator. So let's get back to that distributions area. Didn't actually answer the question in hindsight. Now can we go to distributions now? When we're looking for a number or culminating number of values, we go to BCD. And your lower limit is, so it's the same probability, the same number of trials. And your upper limit is 1, your lower limit is 0. And you shove that in and you should get 0.7? 0.74. Now can we please verify that? By putting 5 to the power of 5 on 6 to the power of 5 plus 5 on 6 to the power of 6 into our calculator and see if it gives us the same value. So 5 over, that should be 0.74. Yep, does it work? Awesome. Does that make sense? So this is something that we do for tech free. Would I advise doing it if you don't have to? Absolutely not. Cool. What I would be writing down if I was doing this on a tech active question is that, and then writing using graphics calculator for me. What can you tell me about the likelihood of there being 3 or more? It will be what? 0. What was this one? 0.2. This one was 0.2, correct? And this one was 0.74. So the probability of being 3 or more would be 0.06. How did I know that? Because that's 2, that's 1 and 0, so anything more than 3 is going to be 1 minus that, which is going to leave me with 0.06. 0.2 plus 0.74 is 0.94, correct? Yeah. Good, so 1 minus that will give us 0.06. So the probability of there being 3, 4, 5 or 6 4s is 6%. Ish. You would in that situation, yeah. But in a tech-free exam, I wouldn't give you a question where you couldn't evaluate it. I'd give you like 1 or 2 to the power of 4 or 5. Sweet. Awesome. So now we're charging on with the Atomy, and then we'll come back for a GIM kit.